All right. Okay, so chapter 20 in the cardiovascular system of open stacks, cardiovascular system, we move into blood vessels and circulation. Now, again, we've already started discussing a little bit with blood vessels uh, as far as this. Do you need to read this entire chapter? The answer is no. When you go back into Blackboard, well, in fact, I'll do it right now. I'll pull up Blackboard units. If you go into Unit 8 in Blackboard, it's easier to show you than to talk about it. There we go. So I put under the heading what, in essence, what you're going to want to focus on. So chapter 18, blood, you pretty much the whole chapter in there. 19, you really just want to focus on 19.1. 19.1 just talks about the structures of the heart. And then chapter 20, you want to look at, which is what we're getting ready to do now, 20.1, which is just going to go through the basic structural differences of the three blood vessel types. And there are a few subtypes that we'll get into. And then 20.5, so you don't need to do anything with 2, 3, or 4. That's all physiology. 20.5, however, does get into a little bit of activity or action regarding the naming of the specific blood vessels. So we'll do that at the end of our chapter 20 discussion. And then 21.1 is 21 is the lymphatic and immunity, but 21.1 is really all we're going to focus on, because next semester, again, we do spend a good week to 2 weeks going through immunity and what are antibodies, what are antigens, what are how does all of this work. So again, so tonight it's going to be fairly brief. I've probably spent more time getting us to talking about the new stuff as we are going to spend talking about the new stuff. So that's not true. We'll spend a little more time. But anyway, we only have 3 sections to cover tonight. So I just want to show you that. Let's get back into here. Okay, so blood vessels. First thing that we generally, before you probably took an anatomy class, I mean, even when we were kids, we could see veins. I, I know my dad's family, my mom's family, they're all farmers and truck drivers and tradesmen, and so they had big forearms. And this is not a selfie, by the way. No, but so anyway, maybe about 30 years ago. But yeah, this is veins generally are going to be more superficial. So just as we think of blood vessels, a vein is just one type of blood vessel, and I think we've probably made that fairly clear by now. So as we look at a similar illustration as we saw last week regarding the heart and the circulatory pathway of blood from the heart over to the lungs and then back to the heart and out to the body, we discussed a couple of blood vessels already. So one thing, I'm not going to stay on this slide for very long, but I do want to again just refresh your memory from what we saw last week. We see that the red is indicative of oxygenated blood, and we also see that blue is going to be indicative of low oxygen blood, or blood that's going to be higher in carbon dioxide. So that's what the color coding means. And then in between, we have kind of a purple color. Red and blue, of course, make purple. So we do see what are called capillary networks or capillary beds. So we'll definitely spend some time looking at more specifics regarding the capillaries. Now, I do want to, again, reiterate that red means oxygenated. It doesn't, however, mean artery. For the most of the time it does, okay? But it always means oxygenated blood. So keep that in mind too. Blue always means low oxygen blood. And you'll recall that again, we do have 2 special arteries and veins that are the pulmonary group that are carrying the opposite oxygen and carbon dioxide. So we do see pulmonary arteries carrying low oxygen blood. They're the only arteries where we see low oxygen blood. Pulmonary veins are the only veins that we're going to see blood that's rich in oxygen or high in oxygen. So, but other than that, I think we again see this pulmonary circuit. We're coming in. So this is a quick review and rundown of what we ran through last Thursday, right? We've got right side of the heart receiving all of this low oxygen blood from the body and then sending that blood over to the lungs. So that's the pulmonary circuit, right side, half of it, right side of the heart, sending blood over to the lungs to get rid of that CO2 and to exchange it for oxygen. So then we're going to send that oxygenated blood back to the heart. This time it's going to go to the left side of the heart, and that really completes what we call the pulmonary circuit. So it's very important that, and we'll see it again next week, or actually on the Thursday, we're going to start looking a little, I mean, cardiovascular segueing into pulmonary and respiratory is perfect. So we're just, like I say, we're going to keep the train moving. And Thursday, we're going to start looking at respiratory in a little more detail. So we'll see the pulmonary circuit again, is my point. So by the time we're done, we'll have spent three or four classes discussing pulmonary circuit. Okay, so I think at that point, hopefully, if you're faced with questions about high oxygen blood goes what direction, low oxygen blood goes which direction, what side of the heart has which, hopefully by after Thursday, you'll have that etched into your brains. Right side, low oxygen blood, sending it to the lungs. Why is it send it to the lungs? Because it's low in oxygen. So then we get the oxygen exchange. We send that blood back to the left side of the heart. That's all the pulmonary circuit. Then the left side of the heart sends all of that blood that's rich in oxygen out to the body systems. We call that the systemic circuit, or at least half of it. The second half of the systemic circuit is the venous return back to the right side of the heart. So systemic circuit is left side of the heart, out to the body, back to the right side of the heart. Okay, so kind of two circuits, two pathways of blood flow. So so that's a review. We know this already. So we're going to go a little bit further and break down some of these specific blood vessels. All right, first of all, when we look at the structures of blood vessels, we do see this is really kind of our introduction to tubes. So we've seen a little bit of tubing up to this point, but not as specific as this. So and again, the rest of the semester, the rest of our body systems are all going to be focused on different tubes. So the structures and the makeup of these structures, these tubes that we go through now, we're going to see similar features coming up in really the rest of the semester. So we finally made it. All right, we've talked about tissue types, and we talked about epithelial tissue being a lining or a covering. We talked about connective tissue being where we find a lot of vascularization and nerve tissue and ground substance, kind of where we the matrix, and again connecting that epithelium to the next type of tissue, which is the muscle tissue. So when we look at muscle tissue, again, we're thinking of three muscle tissue types: skeletal muscle first, and we spent a whole chapter going through skeletal muscle, and then we got into cardiac muscle just last week. Well, now we finally made it to smooth muscle, the third muscle type. So that's where we are now. Pardon me. Take that frog to the pond. So, so anyway, we look at arteries and veins. We are going to see smooth muscle involved. We're going to see epithelium involved. We're going to see connective tissue. We're going to see all three tissue types, and even nerve tissue. kind of spread throughout. So let's take a look at arteries and veins. And again, I know these are a little bit small, so the next slide we'll blow these up in a little bit more detail, but I did want to leave some of the verbiage on there. We look at the lumen, or kind of the opening where the blood is traveling. Yeah, hold on a sec. Somebody's maybe got a question. Oh, I know. I need some water. I'm I'm in the basement, right? And you probably know that, but like Joe Biden, right, in the basement. So, um, but now he's not. He's probably going to be in the White House, but he could be in the basement of the White House. But I've got a dehumidifier, and it's usually like it's set at like 45 or 50, and that thing's always pretty much going, right? Gosh, the last 3 days it's been at like 31, 32. It's sitting at about 34 right now. It's dry as a bone down here. Plus, I got a space heater, which isn't on right now, but it was on earlier. So yeah, it's really dry down here. So yeah, I probably do need a drink of water, or I should just stop talking and let you guys go for the night. I bet you'd like that. Well, too bad. Well, you can. You're free to do whatever you want. I'm not your guys' keeper. But anyway, I'll keep babbling, and if it gets to the point where I need to go grab a quick glass of water, I'll do it. I need a little bell so I could have one of my three maids. Gosh, this is recorded. I got to be careful. One of my three wonderful ladies of the house have a little bell, and they could, yeah, right. Anyway. Uh, Okay, so why would I appreciate that, Amanda? Good. It's better than what's on the idiot box, probably. Um, so yeah. Plus, you get to learn something, so that's even better. Although there's some good TV, right? Well, hell, there's so many channels and subscriptions to pick from. You can't go wrong somewhere. You're bound. It's like fishing, right? You throw your pole in enough, you're gonna catch something. So, but anyway, it's a good time of year with this. Like I said earlier, with the tube. So I've got a lot of competition right now. So I better keep you guys entertained at least a little bit. So anyway, you have that epithelial lining that is going to be where the blood is making contact. Okay, that's going to be called the tunic. Okay, the internal tunic specifically. So a tunic is kind of like a cape or a robe. So we've got the tunica intima is going to be the innermost layer. That's going to be the epithelium. There's a little bit of connective tissue there as well. You can kind of see the squiggly dark line. And again, I have bigger images of this, or illustrations I'll show you in just a second. And then the media, tunica media, is going to be the smooth muscle aspect, the muscular layer. So we have epithelial, a little bit of connective, and then muscular. And then the tunica externa is going to be more connective tissue. So this outer layer, this tunica externa, is going to connect with potentially muscle, or skeletal muscle, like fascia of skeletal muscle, for instance, maybe hypodermis. So anyway, more connective tissue. That's the tunica externa. Now, veins and arteries look very similar to one another, but there are some definite differences. We'll get into them in a little more detail in a few minutes. But right on the surface, we can see that the muscular layer is a lot thinner with the vein than with the artery. And it has to be that way because every time your heart beats and ejects blood, the arteries are what are receiving that blood. And so arteries have to withstand a lot of force and a lot of pressure from the blood that's being pumped against the walls. So there's going to be some extensibility or some flexibility, certainly. So we'll look at some of that as well coming up. But anyhow, let's keep her going. Here we go. So we look so we'll start with arteries. In essence, we're going to go arteries first. And then remember, arteries feed their blood into capillaries, and then capillaries dump their blood into the veins, and then we end up back at the heart. So we're going to start with the artery aspects, some of the real basic structural features, and then we'll look at capillaries and then veins. All right, so that's where we are now. We have what are called elastic arteries and muscular arteries. Now, we also have what are called conducting arteries. Conducting arteries. The aorta would be a main conducting artery. It's the conductor, right? And so it's going to have, it's the main artery. And so it's going to have branches that come off of it, and those are going to be called distributing arteries. So we're going to have distribution arteries that go out to the appendages, for instance. And some of those are going to be more embedded within skeletal muscle. So their arteries are generally quite a bit more protected than veins. But yeah, elastic arteries have to have a little more elasticity. We do see that smooth muscle layer is quite a bit thicker, even than the muscular arteries. So these elastic arteries do have to withstand more of an increase or change in blood pressure as the heart contracts, as the ventricles contract. So these would be conducting and distributing arteries. Again, are going to be more peripheral. And again, you can see a lot thicker connect. So the thickness is probably pretty much the same. It's the thickness of the individual layers that's a little bit different. So we do see the tunica externa and the muscular having a little bit more connective tissue being a little thicker because again, it's going to be kind of embedded or surrounded by skeletal muscle. Now, as arteries start to get closer and closer to a capillary network, they do taper or get smaller in diameter. So we do see the arteries actually become what are called arterioles. So you can see that OLE on the end. And again, whenever we have an ELLE or a L at the end of something or a UL or an OL at the end, a ULE or OLE. It typically means little, whatever it's describing. So arteriole, in essence, means little artery. So again, as arteries kind of taper and get smaller, they become what we call arterioles. All right, so that kind of takes us towards the capillaries next. All right, so now we're in a capillary network, and I have some other illustrations coming up that'll kind of put all these puzzle pieces together, but we're going to take them separate for now. So, as an arteriole dumps into a capillary network, we do see three different capillary types or three capillary possibilities. First of all, right off the bat, when you look at these capillaries, you should maybe notice I'll go back and forth, artery versus capillary, and we don't have that muscle layer, right? Even the arteriole has that smooth muscle layer. Okay. Capillaries, remember, are the only vessel where we can get anything out of the bloodstream or into the bloodstream. So we don't need thick muscle layers. They're uh, that's not their goal. Their goal of a capillary is to be able to have some sort of permeability. Now, how permeable is the capillary? Well, that depends on a few different factors. Part of it is its location. So we see what are called continuous capillaries, and notice we have certainly an epithelium. Okay, so we have a lining that the blood is going to be in contact with. The continuous capillaries are going to uh, kind of like the name implies, we're not going to see a lot in the way of items diffusing out of the bloodstream or into the bloodstream with a continuous capillary. So we may see as an artery becomes an arteriole and then connects over to a venule and then a vein. We may have a capillary that's just continuous where we're just kind of shuttling blood through. We're not necessarily distributing it out to other capillaries within the bed. So we may see that during times of extreme stress where the abdominal region and the abdominal viscera uh, usually vasoconstrict, and we send blood away from the viscera and out to the appendages. So some of that arterial, as the heart's pumping fast, that arterial blood may not really need to stop in the capillary bed and drop off a bunch of nutrients down in the abdominal viscera. So we may just want to shuffle that blood right across. So we'll see what's called an anastomosis. That sounds like a mouthful. So I'll show you what it looks like written out, so you don't have to try and guess what it is that I'm babbling. So anyway, we can connect an arteriole right over to a venule. We don't necessarily need a capillary network. So we'll see that. But if we do have a capillary network, we can also see what are called continuous capillaries. So anyway, what the most common capillary that we're going to see is going to be called fenestrated. Fenestrated means windows. Fenestrations are little pores. And in French, I think fenestra is window. So anyway, it's good. So it's going to be Latin. So the Latin for window is right in front of you, fenestra. So little tiny windows or pores. This is the bread and butter of what a capillary is going to be doing, right? Dropping off nutrients, picking up waste. So this is going to be very common. Now, sinusoids, little sinuses, and a sinus is going to be some sort of opening or a room, typically we think of. In this case, it's going to be a large opening or a large gap. So in the lining, in that epithelial lining of the capillaries, we do see larger gaps or holes or pores called sinusoids. Now, why would we need something that looks like this? Well, probably because we need a whole bunch of blood to get dropped off. In fact, we're okay with not necessarily worrying about the exact balance of micronutrients or gases or whatever. So we may see sinusoids in the liver, for instance, where the liver is a large filter. So as blood gets to the liver into the capillaries, we can drop off a whole bunch at once. We don't have to nickel and dime it through these little tiny holes. We have large sinusoids. So remember, structure fits function. So the liver function is to filter, receive a reservoir. It does a lot with blood. So how do we get a lot of blood dropped off in the liver? Well, why not put a lot of big holes in the capillaries of the liver? So that's what we have, sinusoids. So here's the kind of what I was talking about a second ago, this anastomosis, and then we'll come back up here to the capillary bed. But we can see an arteriole over here on the left, and then we have what's called an arteriovenous. So it just means artery and vein, arteriovenous anastomosis. And an anastomosis is in essence, it's like it is what it says. It's like a direct link or connection of two different types of vessels. So there's no other real way, I guess, of describing it. Basically, it's where vessels connect with one another. It's an anastomosis, and so we do see this again throughout the body where we may not need. It's almost like a bypass uh, route. It's an external or not external. It's an alternative route or pathway for moving blood. And again, we may need to get blood shuttled over to a certain area quicker, and so we don't want it to have to go through all of these different side roads to get over to the venule and get back up to the heart, or to get to the liver and then up to the heart. So we do see these throughout the body, strategically located. Now, one thing we see, so let's move away from that and go back to our capillary network. We see as the arteriole kind of branches off and comes into the capillary bed, we have several little sphincters, and these little sphincters can basically regulate how much blood we're going to be sending up into the capillary bed. And what would determine that? Well, multiple things. Primarily would be, so this this capillary bed, if we look at the negative space, all this negative space, the white area, you could envision that being little cells, and this whole thing being, like a collection of cells. So this is a tissue. So capillary beds are going to feed cells, and they're going to be located within tissues of organs. So anyway, depending on the needs of the cells, right? If the cells are really hungry in this particular tissue of this particular organ, then all these sphincters are going to be relaxed, and we're going to try and get as much capillary flow going into all of these different pathways. Okay. Now, again, during stressful situations, I may not need as much energy, or maybe during sleep, right? There are certain areas maybe that get attended to, and other areas that don't. So really, all hours of the day, right, sleeping and waking, we do see different needs being met, nutritional needs being met, hopefully by, again, the delivery of the blood through these capillary beds, and the dropping off of the nutrients. Okay. And again, I can regulate all of that with these little sphincters. And again, if it's a stress situation, I don't need to feed this area at all. I can just run it right through in what they call a thoroughfare channel, or I can run it through an anastomosis. So multiple possibilities for transporting blood from an artery over to a vein. All right. The other thing we see then is going to be the picking up of waste. So, I wanted to mention too, and this kind of goes with what we've talked about before. We've seen blood, and we've seen plasma in the blood. So, as we get blood into these capillary networks, we're going to see, first of all, red blood cells lining up in single file. So the diameter of a capillary just happens to be, so how big around is the lumen? Okay, the diameter of the capillary just happens to be the same diameter as a red blood cell. So red blood cells line up single file, toot, 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 and go right through the tube. I don't know. I don't have whatever. You get the idea. So capillaries are very small, 8 microns in diameter. That's 8 times 10 to the negative 6. So 0 point, and then 5 zeros, and then a 6, or an 8. 8 microns. So extremely small. Okay. So capillaries, so they're dropping off gas. Meanwhile, plasma is getting kind of pushed out a little bit. We're going to see the lymphatic system kind of intertwined in here shortly. So anyhow, this is the capillaries. This is really where all of the action is. Why do we check capillaries? Well, first of all, couple of reasons. One is that really it's an easy stick. I don't have to worry about I'm not going to. Capillary walls are pretty resilient, so there's going to be some pain potentially from the prick itself, but yeah, so you're also getting this is where glucose is going, so you're going to get glucose has been dropped off. So if we check the venous supply, it could, depending on which area of the venous supply, blood sugar levels or blood glucose levels may not be an accurate number or determining factor for the overall delivery of the glucose. So yeah, segueing right into, why do we have capillaries? What are we doing here? Well, yeah, we're dropping off glucose primarily, right? We're dropping off oxygen secondarily. Those two, you have to go to the mitochondria of the cells so we can convert that into energy, or ATP. We're also dropping off amino acids, fatty acids. We're dropping off vitamins and minerals, uh, hydration, water. We're dropping off ions. So there's a lot of stuff getting dropped off in the capillary bed, and glucose is the big dog. So we could see high glucose levels in the arteries, and then we drop off that glucose in the capillary bed, and then over in the venules, we may see we should see fairly low levels in the venules. But again, if we don't have enough insulin, then you know, that glucose is just going to kind of hang out in the blood of the capillary network, because ideally when there's enough insulin, the glucose is going to leave the interstitial area. It's going to leave the bloodstream, the plasma area. It's going to leave then the interstitial space, and then it's going to ultimately go inside of the cells. So if I find a lot of blood glucose in my, just kind of hanging out in this area, then that's a signal maybe that I'm lacking some insulin. So um, and it's doesn't really do a lot of damage to be able to check your glucose in those, from those capillaries. Okay, so anything else with capillaries? Let's see. Eight. So that, yeah, there's small, 8 microns in diameter. You don't need to know the specifics, but a capillary and a red blood cell are the same diameter. So red blood cells literally line up single file. Microcirculation. We'll look at a little bit of microcirculation next semester, because we'll get into details about what exactly is being dropped off, what amounts, how do we get diffusion to take place, how do we get electrolyte balance, fluid balance. How does all that work? So we'll get into more of the details next semester of that. And we'll look at microcirculation and see how red blood cells line up single file. Now, lastly, for blood vessels, we do look at veins next, and veins, well, venules first, technically, let me go back to this slide. As we leave the capillary bed, we're going to enter into a venule. Hey, and then that venule is kind of going to taper. The other's going to, I don't know what the untaper. I don't know, it's going to get larger. So we're going to go the opposite direction of what we saw with arteries. Arteries go from larger diameter to smaller diameter till we get to capillaries, and then veins go from small diameter and then they get bigger. So as we go closer to the heart, so veins go toward the heart and their diameter gets larger. Arteries go away from the heart, their diameter gets smaller the further away they go. So anyway, venules, not as much. First off, we can see that and we already mentioned, the muscular layer is a lot thinner with veins. Now, again, this does get into a little bit of physiology with blood pressure, but I will mention it again, that arteries, so at the aorta, when we eject blood from the left ventricle into the aorta, that's the highest pressure, blood pressure area in the body. It's the most amount of pressure where that blood is being ejected from out of the heart through that aortic valve and into the aorta. So as we continue through the body, that blood, the pressure starts to get less and less, right? As we get further and further and further from the heart, we're going to see the pressure go down just a little bit, not a whole heck of a lot, but it is going to decrease. And then once we get to the capillary networks and then into the venules and into the veins, we see the blood pressure is extremely low. So in essence, let me go back to this slide here. This is a perfect slide. You can see that this is one connected tube, and it just happens to have a pump in the middle. So this tube, if we start the tube, we could start it anywhere, but if we start it at the aortic valve, it's just one continuous tube. Okay, goes right back and plugs into the heart. So this side of the tube where I pump the hardest and eject the blood into the aorta, that's where we're going to see the highest amount of pressure. And as we get further and further away and we see the diameter decrease and we start to get over into the veins, now the pressure over, if the pressure is highest at this spot of the hose where the pump is, then where the hose is going back into the pump is going to be the lowest spot of blood pressure. So veins don't have to withstand a lot of stress against their walls, so we don't see a lot of thick muscle. All right, so anyway, venules and then veins. These do have the same 3 layers, the same 3 tunics. You've got the epithelial lining with a little bit of connective tissue, and then a muscular layer, the tunica media, and then the tunica externa. All the way on the outside is going to be a whole bunch of connective tissue. And the other thing we see with veins, so again, in veins, by the way, this is where you're going to do your blood draws from veins, because again, there's little to no blood pressure. So when you break the wall of the vein with a needle, you're not going to, have, the heart isn't pumping directly into that area. So you shouldn't have blood spurting. If you do, then you have an artery that's been punctured. So with veins, again, we should just be able to go right in. Blood's going to come right out. Maybe you get a little bit of bleeding afterwards, and that's it. It should be quick. Should be almost relatively pain free. If you have a good phlebotomist, or if you yourself are a good phlebotomist, the patient shouldn't even know they shouldn't even be able to really feel much of anything. So, but yeah, you don't want to go in and move around and you didn't get it. And yeah, so you want to make sure you get those veins and get them in. Some of them roll, so you got to get a lot of practice. But as you get good with practice, man, it's smooth sailing. You're going to hit that median cubital vein every time, get your blood draw, move on with life. So that's what we see with veins. We don't want to do that with arteries. We do blood pressure and pulse checks with arteries, right? Because we're getting that hard pulse, the ventricular contractions increasing gives us that pulse rate, as well as the blood pressure. So we'll talk about just the kind of the location of some of these key arteries in just a few minutes. But I'm going to move on from veins. I do want to mention that we have valves in veins. Valves, which I've got a little illustration shortly. Whenever you see valve, of course, we're thinking prevention of backflow. So we find that veins do have valves to prevent backflow. And again, if these valves become compromised, then we're going to get backflow, right? And that leads to edema and fluid imbalances. And then the kidneys have to work a lot harder to balance fluid. And then next thing you know, the kidneys are failing, and, edema is built up, and we've got we've got congestive heart failure on top of it. So yeah, these valves play an important role. We want to we want to keep the line moving, right? Keep her moving. We don't want backflow. All right. So this is more or less FYI. This is figure 20.9. It just gives you a nice little glimpse into where do we distribute all of this blood. You've got about 5 liters of blood, by the way, and that just so happens to be, and we're going to look at what's called cardiac output. How much blood does the heart pump out per minute? So we'll look at heart rate. We'll look at cardiac output. We'll look at what's called stroke volume. We'll look at all of that next semester. And what we're going to see is that it's quite fascinating, but cardiac output, so how much blood does your heart pump out per minute, okay, is about how much blood you have. So that's kind of cool. You've got about 5,000 mLs of blood, roughly. I mean, there's a range depending on body type, depending on age, depending on even gender. So there's multiple, like everything in A&P, right, guys? There's a range. So the range of blood amount happens to be right around 5 liters of blood. And so that also happens to be about what your cardiac output is. So all of the blood in your body is getting pumped through your body each day. It was to put into help. Yeah, catheter. Good. Yep, absolutely. Yep, it's a catheter. And catheters help for running lines. Yep, for sometimes we leave a catheter in to be able to inject some sort of medication or to get something pulled out. So we can put things in or draw things out. Yep, with a catheter. Absolutely. Yeah. And they can go in any number of tubes too. Blood vessels, we put them in the urethra, right? The catheter there. Open flow, yeah, like after, yeah, stent, yep, a stent, STENT, a stent, yep, that's exactly right. So yeah, if you've got a clogged artery Absolutely. You can sometimes, I think I have a slide coming up in just a second. We'll talk about, it'll be your guys' PSA for the day, your public service announcement on atherosclerosis and plaque. So, so yeah, excellent. So we'll talk about a stent and angioplasties and things like that. So systemic circulation. So anyway, where's all this blood? Where's this 5 liters of blood? Well, 84%. So most of it is going to be in your body systems. We do see 9%, roughly 10% in the pulmonary circuit, and then about 7% in the heart. So, so anyway, that's just FYI. And then 64% of your blood is going to be, so these numbers may be a little misleading. 64, 13, and 7, that equals 84. They didn't break down, these don't equal 100 of 84. So I don't know, that gets into some weird math. And but anyway, 64% of all of your blood is in systemic veins, is in the venous return. Okay, so only 13% is in systemic arteries. Again, it's just FYI. This doesn't, this is FYI too. Again, when you guys start taking some of your clinical courses, and maybe some of you already work in medical, you learned about pulse points and where you can take pulses. And again, certainly the radial artery is a very common spot. This is a good slide too, as we're going to be segueing right now right about now into we're going to be segueing right about now into naming blood vessels. So this is kind of a good spot, because we see these pulse points are going to be arteries for starters, and secondly, we see that some names finally. So I know we've seen inferior superior vena cava, we've seen pulmonary vein, pulmonary artery, we've seen aorta, but that's about it up to now. So this is kind of our first glimpse at some more artery names. And again, they're named usually for location. So from going back into week 1, you guys studied and did your portfolios and started really looking into body region terminology. So with nerves, going with bones, going with muscles, going with nerves, going now into the blood vessels. We see that these items can be named for where they're located. So temporal artery, you don't have to memorize temporal artery. You already know what the temporal bone is. You know what an artery is. Facial artery, there you go, somewhere on the face. Now, carotid is going to be right kind of underneath where that, you can't even see it on me. I got to wade through, but it's going to be right where the edge of the, right around the ramus and the angle of the mandibles, where you're going to find that facial artery. Common carotid, that one, the carotid again has to do with the main blood vessel that's feeding the head and face and brain. So the carotid artery pulse, you're going to locate carotid by finding the sternocleidomastoid, and then you're going to locate the larynx and trachea. Okay, so you'll have the larynx, your voice box, and your trachea, and then the SCM or sternocleidomastoid. They kind of come to a point right there, a little V. And then if you find the border of the inferior border of your mandible, okay, that forms the other part of the triangle. So you can draw a triangle from the corner of your mandible and the SCM right down to your trachea, and then follow the trachea back up to the mandible, and then follow the mandible. That's a triangle right in there. That dip is where you find the carotid artery. Okay. Brachial artery, that's a common one that you'll use when you do blood pressure. So radial artery, again, that's well, hell, nowadays, I don't know, maybe some of you still do it if you work in the clinicals or in the clinical setting. You got your watch, or I don't know, your watch, and you're watching the second hand, or you're looking, some people still do that. Right. Nowadays, though, everything's electronic. You can put a little pulse oximeter on your finger, get your pulse rate, and get all kinds of other info. All right. So anyway, femoral artery, kind of in the groin area. This is maybe a little too proximal, but the femoral artery does begin right around that area, and then popliteal behind the knee, posterior tibial, dorsal pedis. So the point of this slide is really just to kind of show you that names of our introduce you to that idea. Now, when we look at uh, uh, when we're going to move out of vessels in just a few seconds. But before we do, here's your PSA, your atherosclerosis or plaque talk. Again, we do see this plaque buildup is going to be a problem in a lot of areas. It's primarily a problem when we look at the coronary arteries, or the arteries that actually feed the heart itself. Part of the big problem, certainly with having plaque here, I think it maybe goes without saying, but if I want to feed something over here and I have a smaller pathway, so I can fit 10 delivery trucks to get over to the cells that need food when the road's wide open. Now over here, I've got half or two-thirds of the roads closed. Now I can only get 3 delivery trucks out to the cells. So um, that can be a problem. The cells might get a little hungry. They might even demand more because they're used to getting 10 trucks a day instead of just 3. So what's going to happen is the heart is probably going to beat a little harder. It's going to beat a little faster, and then we're going to send, maybe try to get 10 trucks sent through here in a shorter period of time. So over here, I get 10 trucks in per minute. Down here, I get 10 trucks in, but it's going to, I still need to do it in a minute, but I've got to really squeeze and pump hard. So we're going to see an increase in heart rate, an increase in flow rate, and that certainly is going to put more strain on the heart muscle. Now, especially if this is the artery that's kind of feeding the heart, right? That's a cyclical problem. That's a conundrum, they call it. So the heart is getting fed by these coronary arteries, and the coronary arteries narrow. So the heart has to pump harder to get the same amount of blood to itself, but because it's beating harder, it needs more ATP, so it needs more energy, so it needs more blood going to it. So, that's the dog chasing its tail, there. So, we really need to address that. And there are a couple of ways in which we can address plaque buildup. Before I get into those, understand that why this plaque might be there. I think it's pretty evident to most of you that, or probably all of you guys are sharp. I was going to say fart smellers, but I think I meant smart fellers. You guys are really sharp. So you know that plaque buildup is probably due to diet, right? It's something to do with bad cholesterol, bad fats, and not enough good fats and omega 3s, and right. That is true. That's very true. Sodium, right? Blood pressure. There's all kinds of factors, but there's also a genetic mutation. There's an anomaly on a specific gene that is going to involve not necessarily having enough of a specific enzyme that enables this process of keeping your arteries clean to occur. So we know this now, right? The Human Genome Project has opened up a lot of doorways to understanding kind of what's going on and why, a 35, 40, 45-year-old healthy individual ends up at the coroner's office, not for a visit, but on the wrong side of the table there, because they've had a massive heart attack. And by all intensive purposes, we see that, you know, they're healthy. They didn't smoke. They didn't drink. They didn't have a lot of stress. They ate right. Or whatever, right? I mean, none of us, hell no, all of us have our guilty pleasures, and all of us do things we probably shouldn't. And yet we live quite a while. So how come some folks drop dead at young ages of massive heart attacks? Well, it's quite possible that they have that widowmaker gene. And yeah, so we know this now. We've been able to isolate it, and so we can bring in the whole family and run them through after the morning, of course. And say, hey, this is what we have. You're going to want to get, you've got kids, you want to get them checked, right? So then, yeah, run everybody through, and maybe one of the buggers has the gene or the mutation, and so then we got to keep an eye on little Billy or whoever, right? We got to keep an eye on him. Maybe probably for the rest of his life, but that's okay because, if we didn't know about it, he, he all the best diet in the world may still lead to that at a young age because of the gene mutation. So he put you on some medication and keep you watching your diet and activities, and man, you'll live till you're 80 or 100. So anyway, how do we take care of this if it does? So my point is, there's a lot of reasons why this might be there. How do we take care of it if it is there? Well, again, we could get you on some cholesterol drugs, what they call statins. There's a whole class of drugs that help to take care of business with the cholesterol and help kind of keep those levels down. So that's the first thing we'll try. The other thing, we know that if you do have cholesterol problems, that you probably have some blood pressure issues, because again, the heart's been having to work harder, thus increasing pressure, thus creating maybe new set points, all because we've got some plaque buildup in the heart. So probably going to put you on some sort of blood pressure medication too. And we also probably thinking about kind of going along with the blood pressure med, probably going to put you on a blood thinner because the heart doesn't have to work as hard if it's pumping thinner fluid than if it's pumping thicker fluid. So we're going to try all that first. And we're going to discuss lifestyle. We're going to discuss, a couple other the basics. And we're going to keep an eye on him. Comes back in and run some tests and maybe some stress tests too. Make sure everything's good and just watch the progress. And if nothing's working, right, then we may, or if they came in and it's so bad that even if I dump a bunch of cholesterol drugs in you, it's not going to help, we could try doing an angioplasty. We do an angiogram where we can go in and put a camera in and maybe take a peek. How occluded are we? How blocked is it? From there, if it's bad, we can put an angioplasty. It's almost like a balloon animal pump. They stick the balloon in and then you start pumping, boop, 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 and then the balloon fills up and extends that the diameter a little bit, and then I can run a stent in there. It's kind of like one of those Chinese finger traps looking deals. Run one of those babies in there, pull everything out, and boom, we've got a stent, like a Chinese finger trap in, kind of keeping our artery walls more stable. We could put some mesh in there too. Maybe we could catch some clots that might be floating around. So yeah, we've got some options. Whoa, 15,000. Oh. I mean, that's like X-Files, Laura. Is that another Racine or Kenosha deal? Yeah, I mean, that's, is that the eyeball guy's cousin or something? Maybe same guy. Huh. Like I say, I'd bring Mulder and Scully in on that one because that guy might be from another realm. You see? Well, look, Craig. No, nothing. I just can't remember where Lori said she worked. I don't remember. It's one or the other, Racine or Kenosha. Well, okay. Well, there you go. See, I told you guys, my memory's pretty good. Some days, take my ginkgo biloba or biloba. Oh, that's Rocky Balboa. Ginkgo, and some ginseng and yeah, good clean living. Yeah. The hood of Wisconsin. Yeah, I know that. Well, I don't know that. I've only been to Racine. I have to go there once a year, to the main campus for meetings. Sometimes twice a year. Usually it's a whole day, but I'm just at the campus and it's beautiful. I'm get to the I don't know if you've ever been to the Racine campus, but man, on a beautiful sunny day, looking out over the lake and yeah, the crystal blue waters. Yeah, it's a pretty campus. But you know, so I've been to Kenosha a lot more. I've taught at that campus a few different times, and um, I haven't really. But it's like you just go right to the campus. I was living in Lake Geneva at the time, so I just zoom right over to the campus and then come home. So it was a night class, so I didn't. I'm sure I wasn't missing much. I know I drove by a Walmart, but that you drive by a Walmart everywhere, right? You just get in your car and drive a few minutes. You'll probably drive by one. Hey, so anyhow, I grew up well, I didn't grow up. Well, I kind of grew up there, I guess. At 18, well, I was born in Rockford, Illinois, which is kind of the Racine of Illinois, the armpit of the Midwest. Although, between Flint, Michigan, and Racine and Rockford and Gary, Indiana, that's kind of a rough group of cities there. But so yeah, I know. I'll tell you what though, man, there's usually a lot of really good independent restaurants in those towns. I know Rockford has great uh, Italian food, Indian food, and soul food. They've got a lot of really good mom and pop restaurants. So I don't know what it is about some of the dumpiest cities with the highest crime have some of the best food. So I guess if you're you got to have a reason to stay, I guess. So it might as well be food, right? Plus, yeah, if you're sick, or you're like freaked out, you need some comfort food. Um, so yeah. So anyway, Infusinos. That sounds like an interesting play. That's a neat name. Is that in Racine? I have to check that out. I like the name, if nothing else. Being a medical person, I would think, yeah, Infusinos. We infuse flavor into your brain. All right. So anyway, yum, Infusinos. I'm in. I don't know if they deliver out to Beloit. Yeah, good pizza. Yeah, I live in Beloit, and man, there's nothing here for pizza. No offense, Craig, but Domino's is. I guess this isn't offensive, but I mean, the best pizza in Beloit is probably a chain. Right? I mean, I can't find anything here. I'm willing to drive. No kid, no joke. I'm willing to drive 40 minutes down to Rockford to get real pizza. So, but no, just teasing. Sort of. It's hardly food, and you know that. So anyway, we look at vein. Oh, yeah, we're almost done. How do we get venous blood back up to the heart? It's easy to pump blood, eject it, get it traveling throughout the body, but how do we get blood moving back against gravity? Well, we have skeletal muscle pumps. So we strategically have vein placement, oftentimes kind of in between muscles. So like the soleus gastrocnemius connection, right? The back of your calf region. So in the back of your lower leg, posterior lower leg, you've got the flat soleus muscle, and then you've got the gastrocnemius right over top of it. Well, running right through it, I do have a little visual aid. You've got a vein running right in between them. So every time I contract that gastrocnemius, I'm going to get blood moving up uh, superiorly. And again, these valves are going to help prevent backflow. This goes back to the sedentary lifestyle being a bad idea. We don't need everybody prepping for the next 5K But we do need some movement. We need some activity. Even if we can get them on TheraBands, I mean, hell, they could be sitting watching Days of Our Lives and kicked up with the watching Stefano come back for the third or fourth time this month, and hook up the blue tube or the red tube to your ankle. Get the meow mix or the shaker for your kitten, and have your cat come sit on your lap and watch Days of Our Lives, and just be moving that knee and stretching, pointing those toes with that TheraBand. You don't even have to do anything. You could that's moving. So when we talk to our patients, we have to respect, first of all, that they probably have a variety of shows that they love, so we can integrate some basic movements into things that they actually like to do. We don't want them to feel like yeah, we're asking them to break a sweat. I mean, phew, that's dangerous, right? They might have to drink water to replenish that bead of sweat that dropped off of their forehead. So, but we do need to encourage them to do little bits. Okay? Little bits. Anything is better than no thing. So, like I say, we don't need peak fitness gym memberships, and you know, well, some of us might. I'd like to go swimming. I don't know. I know some hotels, I know Americans and some other hotels, you can go in and pay them like $40 a month, and you can have, they have like an open swim. You can go in and swim whenever you want. I need to check into that. It's like swimming. Yeah, especially, yeah, swimming's good for you. It's a very healthy for the cardiovascular. It's no impact on the joints. So again, we like to encourage hydrotherapy as well to our patients. And again, if they do want to join a club, you want to make sure that they're joining a club with a pool, so they can, or the Y, right? The Y is great for that. So yeah, get your patients going in water. It's really healthy for them. So yeah, so swimming is awesome. So if you can do it yourselves or get your patients to do it, then that's good for them. We've seen all this before. Oh, we're almost done with this chapter. I just want to discuss a couple of specific arteries and veins, and then I want to talk just a few minutes about the lymphatic system, and then we're already, man, we're rounding third, heading for home. So we do see something we've seen before. So we'll start with naming our vessels right in familiar territory. So we see the superior and inferior vena cava dumping into the right side of the heart, then that right side pumping into the pulmonary trunk, leading us out to the pulmonary arteries. Okay, and then we end up at the pulmonary capillaries. And on Thursday, we're going to kind of start right in this area talking about pulmonary capillaries, and then we're going to kind of work our way out as we discuss the respiratory tract. Okay. And then we head back, right? Pulmonary veins heading back over to the left side of the heart. All right, so these images are from OpenStax. They're very similar to what you would see in Visible Body as well. So again, I encourage you to check into Visible Body, especially as you start working on your homework assignments. Okay. I'm not going to spend a heck of a lot of time on this specific slide because it's hard to really read all those little tiny print terms, but you do want to check this out in your text if you have the inkling. And really the idea is to not memorize every single one of these arteries. It's to recognize, if given a diagram, and I ask you, what is this pointing to? And you already know this area is near the clavicle, and it's probably subclavian. If I give you a list, and the only one that has clavicle in the list, there you go, subclavian. So it's about recognizing your body regions and then being able to identify, I have a term, can I put it where it's supposed to go? So we know axillary means armpit, and we know brachial means arm. Okay, we have two bones in the forearm, the radius and the ulna. So if we see radial artery or radial nerve or radial vein, we know that we're dealing with something on the thumb side. Okay, there are a few arteries and veins, of course, that don't have the names that make a lot of sense. So we've already seen a couple, right? The carotid arteries, those are kind of unusual names, but I think that's a term, carotid, that you probably heard before you even took A&P. Let's see, a couple others. Oh, the aorta, right? The ascending, it ascends or goes up, and then it's an arch, and then we have the descending. It goes kind of, again, it conducts blood. It descends, and then just and then we have all these distributing arteries off of that main conducting artery. So this whole trunk, as we come down off of the aortic arch and head down or descend, that is all aorta. Okay, so it's a really long artery, very thick walled. Um, this is where we will see it also referred to sometimes as the abdominal aorta. So, but it's ultimately it's part of the descending aorta and then becoming the abdominal aorta. Okay, and then it branches off right around the umbilicus area. And then we do see, again, the names just continue. So you're going to have the iliac arteries. You're going to have inguinal for groin. You're going to have femoral for femur, popliteal for behind the knee, tibial, fibular. Okay, so again, artery names, I think for the most part, are really straightforward. Now, I do want to discuss a couple of items here as we zoom in. Let me go back here. We're going to zoom in on this area right here. Okay, as we leave that left ventricle and go past the aortic semilunar valve, we go into the ascending aorta, and then we have that aortic arch. Okay, so again, you can see that big aortic arch. We saw it last week when we looked at the heart. We have three major branches that come off of that aortic arch, and they're sort of alphabetized. And now, before I go into the too much of the detail with these, I just want to briefly introduce you to what you already know. So I guess reintroduce you. If I'm introducing you to what you already know, that doesn't make sense. So reintroducing you to cephalic means head, brachial means arm. Okay, you probably already you remember that, right? And then of course carotid, we're dealing with something in the neck. Okay, so keep that in mind as we look at these next two. So the first branch we get, or main branch, the first branches off the aorta are going to be the coronary arteries. So actually the heart feeds itself first. So that's kind of nice. That's smart, right? If it's the pump and the pump's got a pump, the pump should probably eat first. So we do see coronary arteries right as we eject from the left ventricle. But anyway, the first main branches that we see at the top of the aortic arch, the first branch is called then they go alphabetically, brachiocephalic. The second one is carotid. The third one is subclavian. Now, there are a few other terms that go with them regarding direction, and those will make sense here in just a second. So brachiocephalic is the first one. Oops, beep, beep. So it's the first stop. So as we leave the left side of the heart and we go up into the aorta, that first branch that comes off, notice, is going toward the person's right, or towards our right, toward the patient's right. Okay, so the brachiocephalic is going to feed the right arm, brachio, and right side of the head. So it's going to eventually be the right common carotid artery and the right subclavian artery. So, because then subclavian goes out to the arm. So brachiocephalic just means arm head. And it's the first stop. So we're going to see the right side get fed first. So then the second two are also going to feed the same thing. So the second one is going to feed the left side of the head. So we call it the left common carotid. Okay. And then the third one is going to feed the left arm. So it's going to be the left subclavian, which means it goes under the clavicle and then ends up out at the arm. Ends up being the brachial artery, and then they just keep tapering. Okay, so again, as we leave the aorta, or we leave the left ventricle and go into the aorta, get up the aorta, we're going to have the brachiocephalic first, left common carotid, and then left subclavian. So alphabetically, B, C, S. Bowl championship series, right? Anyway, brachiocephalic first. So it's going to be going to the right side, right head for cephalic, right arm for the brachial. Okay. Oh, and it's called common. They're called common carotid. So when we see the word common, it probably means there's going to be two or more items that either come off of it or lead to it. Okay, common carotid. Common means two things are coming together. Okay, so common carotid, as it leaves, it's going to branch off into internal carotid, going into the brain, and external carotid, feeding more or less the face and some of the muscles of the head. Okay, so when the internal carotid goes up into the brain, it's going to hit this area we call the circle of Willis. Okay, you can see the internal carotid right here comes up, and the blood's going to kind of distribute around. We also have vertebral arteries coming up as well. So those vertebral arteries are going to be remember, in the cervical vertebrae, we had those vertebral foramen off to the side, or those transverse foramen, not the vertebral foramen is where the spinal cord goes. The transverse foramen, the little holes off to the sides of the cervical vertebrae, that's where you find the vertebral arteries. So anyhow, all of that internal carotid bringing blood up, circle of will. It's kind of cool. This whole little area looks like one of those like a Hopi tribal figure, like a Southwest. You know what I'm talking about, right? It's got a name. I can't think of what it is. Or it looks like it does kind of look like this would be a worm's eye view. This would be an inferior view. Okay, so this would be looking inferiorly. So we've taken the brain out. We've put it, so the eyeballs would be out front. This is going to be like the olfactory area, and then this is the cerebellum back here, and then this is the brain stem here. So we're looking under, up that way. Okay. Yeah, it looks like baby Groot, doesn't it? Yeah. So anyway, yeah, this is a hot spot. The bacillar artery here is like the base of the brain, and this circle of Willis. This is where a lot of aneurysms tend to form and rupture. I mean, if someone does have an aneurysm, this tends to be the area, and it makes sense. You've got the heart pumping really hard, shooting blood right up to the brain, and then again, where that blood's going up, and it's kind of hitting that circle of Willis right in this area. It's coming up, so the artery's coming in, okay, going up, and then the blood gets distributed. So the roof of the circle of Willis area is getting pounded as that internal carotid comes up and kind of distributes. That artery often gets weak because of the high blood. That's why, like, chronic stress means your heart rate's up all the time. You've got some issues going on, right? So, over time, that can lead to extra stress and strain on the artery at the base of the brain. And again, we see the descending aorta into the abdominal aorta. We've got the renal arteries coming off. A lot of these arteries we're going to discuss. So obviously respiratory, we've already started discussing some of the pulmonary aspects. Next Tuesday, we're going to do a lot of your abdominal viscera and your guts with the GI tract. So we're going to look at a term called mesentery. mesenteric arteries, mesenteric veins. So some of these we'll see in more detail coming up. But again, we see the right arm. We have the right subclavian, so it comes off of the brachiocephalic. It's the brachio branch off of the brachiocephalic, and it comes down, becomes the axillary artery. And then we've got a little circle artery. It circles around the proximal area of the humerus, and so on. And the brachial artery, radial, ulnar. So named for the bone. You know the bones. You know brachial means arm. You know radius and ulna. So yeah, there you go. Okay, same with the leg. It's inguinal and groin and femur and femoral. Okay. Happens to the veins and arteries, the tissues that are being fed. Yeah. So yeah, any distal tissue from wherever the infarct or wherever the problem is, if it's a clog, if it's anything distal, further down the line, yeah, we're very concerned with what we call necrosis. I meant to mention that term earlier. Necrosis means tissue death. So yeah, like with going back to the atherosclerosis, if I get 100% occlusion of one of those arteries, then whatever's distal, whatever gets fed further down that line is not going to get any food. So yeah, the cells will die. We get what's called tissue necrosis. On a heart, it's going to appear bright white, actually. So in an autopsy, when we pull the heart, we can see where someone's had a heart attack. We can see, or an infarct, myocardial infarction. We can see where in the muscle, where, because heart muscle is extremely red, right, because of all of the oxygen need to, because it works so hard. And so if there's it's almost, I've seen them where they almost look, the lines are almost like square. They're like right angled almost. It's wild. And so it looks like somebody took like a oh, I don't know, like a, I don't even know, like a little square tab of paper and just put it right on the heart. It sticks out like a sore thumb. It's a bright white square or rounded spot. That's necrosis. That's dead heart. You think of necrosis, you think of like blackened tissue, and that is true in some areas. But yeah, with the heart, you're gonna see uh, white, bright white. Eh, Okay. Yeah. Yep. Anytime we do, yeah, vein stripping, any type of anything that leads to scar tissue, adhesions, that leads to a diminished diameter, so diminished flow, is going to lead to or even just like problems with the lymphatic system that lead to edema that can, and blood pressure problems. Obesity, we're seeing the obesity epidemic is wreaking havoc on capillary networks, because as we expand fat cells have a lot of capillaries around them. As I make a fat cell bigger and bigger, it actually stretches out the capillaries. So when I take a tube, when I take a tube that's this long and this big around, and then I stretch the tube way out, the diameter of the tube actually shrinks, right? So we know that obesity causes capillary diameter to decrease. And so going backwards, what feeds capillaries? Arteries, right? So if I shrink, so part of the blood pressure that's coming from your heart and into the arteries, into the capillaries, we have to have a diameter that's very specific of our capillaries, so we don't get a backup of so basically we're not getting pressure built up behind where those arteries or where those capillaries have shrunk. And so then what happens distally then in the capillary network, so then it's so heart rate problems, blood pressure problems with obesity, but also we get tearing. Those capillaries will actually, they get so overstretched, and the veins too, they actually get what are called micro tears. And so micro tears get dealt with by micro adhesions. And micro adhesions are basically scar tissue. We saw it last week, right, with coagulation and platelet plugs and spackling, basically the lining of the wall if there's a breach. So imagine just thousands of those tiny little breaches, especially in the legs or just throughout the body. And what happens then, the body repairs those, and part of the repair process is clotting, right? So then you end up with coagulation, excess and adhesions and clotting, and that diminishes diameter even further. And so then you start getting tissue, yeah, necrosis and tissue death. And so yeah, we want to keep an eye on blood flow and the health. Yeah, oh, absolutely. Yeah, we're seeing, yeah, COVID really wreaking havoc on obesity. It's interesting too, because America is one of the few countries, it actually, it's in all reality, is probably the only country where obesity is an epidemic in and of itself. We talk about COVID being this new pandemic. Shit, obesity has been an epidemic now for, oh gosh, at least 20 years. It's been leading to this. So, and yeah, we're seeing now that COVID had their immune systems are shot, they've got blood pressure issues, kidney issues, metabolic issues without COVID. And so respiratory issues. Throw COVID into the mix and they have a hell of a time recovering. And again, they're victims of a system that's promoted this way of thinking and this way of lifestyle choosing, and these so-called diet and fat-free labels that really have nothing but bad artificial sweeteners like sucralose and aspartame. They're finding one thing that COVID really like goes after and gets active with is excess chloride ions, and this is relatively new findings. But as they know more about it, obviously today they did even last week, but they're finding that chloride ions, in COVID, and there's something about its activation and it's like lingering effects and so on and so on. And right, and then you're hearing about anosmia, the like inability to smell and taste problems. And well, I'm telling you guys that aspartame has three extra chloride ions attached to it. That's part of what its side effects are to the body, is your body having to cleave these chloride ions, and then it alters all kinds of ion concentration gradients. And so now we've got sodium chloride ion concentrations high, and so that affects like nerve transmission, and it can affect nerve impulses and hypersensitivities. And next thing you know, it's like frying out the nervous system, but it's also doing a number on the immune system, because the kind of the free radical side effects and the waste that's left behind by consumption of aspartame or sucralose is again having to deal with these chloride ion excess. And so the taste and the smells are always off with people. I mean, I've had some like 2 pack a day smokers come in the clinic that have better ability to taste and smell than someone who's drinking a 6 pack or a 64 ounces of Diet Coke or Diet Dr. Pepper or anything with aspartame. Aspartame addiction is horrible, and it's probably one, and we're seeing the effects of it with COVID as well. They're artificial sweetener is big, 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 big business. Did I say it's big business? It's huge, huge. business. Okay, so aspartame and the artificial sweetener industry. And of course, where do these truckloads and these vats and these barges full of artificial sweetener come from? Well, they don't come, we're not making it here. It's being made elsewhere and shipped in at pennies on the dollar. And then we're putting it in everything. And so it's one of the more volatile things it's a poison that you put in your body. It's completely a-natural. There's nothing natural about it. There's nothing beneficial about it. If you're diabetic, you're better off avoiding anything with artificial sweeteners and just being better with other options. So yeah, man, that's a bugger. And I guarantee that in America has more dependence on aspartame, and oddly enough has way more obesity and diabetes and on, heart disease than anywhere else, and now COVID cases than anywhere else in the world. So if you want to, look at consumption and diet and nutrition and relate that to COVID, slam dunk too. So anyway, yeah. Well, Craig, now we know what your problem is. Mystery solved, man. It's like the Scooby-Doo Inc. gang or the Mystery Inc. Right? Got to solve that mystery. Yeah, we just did. So Craig, flush it, dump it, eliminate it. And I'm telling you, that's in it. You've got to kick it. Kick that aspartame. Kick it further than you'd want to kick anything else in your life. Trust me. You'll be a better person. You'll be a clearer thinker. You'll be healthier on every single level you can imagine. Yeah, get that. You don't need it. If you want soda, drink a Coke. Don't drink Diet Coke. Try it. Yeah. Oh, I do too, Lori. I do too. You could put, I'm telling you, if you snuck a soda or a water with aspartame in it, I can almost smell it before it gets into my mouth. And if I don't, and it gets into my tongue, it's almost like an instant, like I just poured a bunch of decon or boric acid in my mouth. Yeah, I'm with you. Thankfully, I have an aversion to it. Um, yeah, yeah. If you have any loved ones that you really truly love, and I love each and every one of you, and I do not want to see any of you succumb to the side effects and the long-term effects of what aspartames and sucralose. Those are the two bad ones. There are others too. There's even stevia extract. I would be very careful of that one too. If you stick with honey or just cane sugar, hell, stay with high fructose corn syrup is horrible, but it's nowhere near the level that artificial sweeteners have. Yep. Well, yeah. Again, man, you could get suckered into those numbers all day, but I'm telling you, I avoid it like the plague. I wouldn't be diet and make sure if you guys drink energy drinks or those 5-hour energies, Red Bulls, that stuff's also full of artificial sweeteners. So make sure you're reading those labels. I don't drink those either, man. If you're living a lifestyle that requires that much caffeine, then again, we need to have a chat because I'm here to help you guys feel good and be healthy. You want to be a nurse or in medical for the rest of your lives. You don't want to be the patient, and you certainly don't want to be reliant. I'm dead already then. Well, hey, Kreger, if you drink a lot of water, there you go. If you can't, I'm dead already. No, well, we were dying when we were born. So yeah, it's a death sentence, right? Hell before we were born, right? When the sperm hit the egg, soon as that implantation into the uterus occurred in our moms, man, we were sunk, right? So that's why we got to enjoy every single moment of our lives. And yeah, I'm telling you, I see mood changes, I see attitude changes, I see changes that you would never believe. But when people kick that crap, because when they do, uh, I mean, I've seen people I haven't seen in years. I don't remember. I remember faces, but so many names, and you bump into them. Or my dad was down at in one of the hospitals in Rockford. He was dropping something off and for one of his clients, and he bumped into a medical assistant or a nurse that was working at Swedes, and she saw his name and she said, "Oh, do you know Kevin?" And yeah, yeah, yeah. And he was my teacher way back in 2002 or whatever. And he told us I was preaching about aspartame back then. And yeah, I changed my habits, changed my life. I mean, it's no joke. It's really, it's bad news bears. And, again, you, mental clarity is a big deal. Aspartame and artificial sweeteners, they get in the way of a lot of they get in the way of a lot of stuff. Juice, best drink besides water. Yeah, 100% juices, and not yeah, you don't want the 2%, juicy juice. I do honey and water. I do a lot of tea. I go buy celestial seasonings or a yogi tea. If you need a little caffeine burst, I have green tea, and put honey in it, or just straight raw honey and water, shake it up, and yeah, it's that's the stuff, man. A lot of people are doing infusions now. I know several. Okay, good. Yes, there's some people are doing they take water, they'll do like a 12-ounce glass of water. They'll put a little bit of apple cider vinegar, and I'm talking a little bit, like a quarter of a shot, of apple cider vinegar. And you want to get the vinegar that's from the mother, it's called, and that's like Bragg's is a really good brand of apple cider vinegar. They have knockoff Bragg's apple cider vinegar at like Walmart that I think comes from the mother as well, and so the mother plant, it has something to do with the processing. But yeah, apple cider vinegar is extremely healthy, and in water, you never put vinegar straight in your mouth, no matter what it is. It'll burn your esophagus. So you want to dilute it. You don't need much, and then squirt a bunch of honey in there. And then I put some straight cayenne powder. Yeah, like an eighth of a teaspoon, a little bigger than a pinch. And then maybe if I'm feeling real spunky, I'll put a little cinnamon in there too, ground cinnamon. But yeah, cayenne powder and apple cider vinegar and honey, and then and just guzzle it. You don't. That's not a sipping drink there. That's a pound it drink, and then you're good. Poop. That'll perk you up, and that's a cure for what ails you. For sure. And then, yeah, I mean, there's, your daily stuff, like I said, there's some really good infusions that people are doing. They're taking like lemon slices and cucumber slices and infusing them in water, blueberries. Some people do, like smoothies are big. I'm seeing, and they're yummy too. Like Naked is a really good brand. Bolt House Farms, they have some good smoothies. And again, and I know you're all going to say a lot of my stuff's more expensive. It's more, well, maybe, but you don't need as much either. So keep that in mind. I even drink V8s. V8 is yummy. Not the V8 splashes are pretty good too, but just the straight original 100% veggie V8s. Oh man, those are good too. I could drink those by the gallon. But they got they have low sodium, so you have to keep watch all of it. But again, you know we're getting into stuff that's my bread and butter, and I could chat about it all night. So I better move forward. If you, oh, the infusions, yeah. Yeah, they could get that'll get the ball rolling too. That's the thing, a lot of these will, especially if you're not, they're cleansers. They'll get things rolling. The other couple other things that are really healthy for you too that you can add that aren't too tricky or too expensive. Buy garlic at the grocery store and get a garlic bulb, just one, or a clove. Get a big bulb, take off a clove and peel everything away. So you have just a straight up little garlic clove. Chop it up into little slivers and just I'll just put those in my mouth and just eat them. Just garlic. Boom. Yeah, keeps the vampires away too. They come around this time of year, especially. So yeah, so straight garlic's great, and ginger. I have these. I have ginger chews. You can get them on Amazon. You can get them. They used to get them at it was called World Market. I don't even think they have those anymore. But you could get these ginger chews. And again, when I say sucralose, that's the bad one. That's artificial. If you see sucrose, that's just white sugar. And I'm not saying sucrose is great, but it's not horrible either. To some degree, it's okay, right? But yeah, sucralose is no good. But anyway, these ginger, they're like chewable ginger. It's like mostly ginger with a little bit of like tapioca to kind of keep it cohesive. And then I think they put a little bit of sugar or some a little sucrose in them or something. But anyway, yeah, little ginger chews, man, those are yummy, and they stimulate the intestines, get things rolling. Yeah. So, yep, celeries, just hit up your produce department, and pig out on produce. Yeah, isn't ginger so good, isn't it? Oh man. Yeah. Or you can just buy straight ginger, right? Ginger root, just peel it a little bit, just slice little slivers off, and oh man, talk about mm, there's something about that heat that just does it. And again, and yeah, crystallized ginger, so good. Oh man. Whew. Yep. So yeah, bring it on, right? Yep. And like I said too, cayenne powder. Seriously, you get it in your spice aisle, right? Well, uh, you can buy gel caps, like gelatin capsules, and you can make your own cayenne caplets. And you can buy them already that way too, but they're a lot more expensive if they're already done for you. But anyway, cayenne powder. They call it capsicum or capsaicin. Okay, capsicum or capsaicin. Cayenne is extremely healthy since we're on cardiovascular. This is a big one for cardiovascular issues, helping with blood pressure, helping with heart rate. Yeah, straight cayenne powder. You want to mix it with something. Put it in water with honey and apple cider vinegar. Can't go wrong. And yeah, you want to down it too. But all right. So anyway, we'll do more of this type of stuff next semester because we do spend a lot more time kind of on physiology and on like some of what happens when we consume certain things and not consume, that type of stuff. So we do skip the nutrition chapter this semester. We go back into it next semester. So yeah, that sounds like fun, and you're a good group, so you're plenty interested in it. And yeah, sometimes it's easy for us to make changes. And I don't know if it was you, Stephanie, said about your husband. I know, man. Sometimes it's our loved ones they're stubborn, and that's why we love them. But we also want them to be around for a long time, right? We don't want them to suffer, and males generally are more stubborn. It seems like when it comes to doctor's visits and making changes and lifestyle changes, and because we are, we're indestructible, right? We're resilient and powerful until we're not, and then then it's a big deal, right? We're the biggest wimps on the planet. I mean, God, my dad, he never got sick, but when he did, it was like the whole world had to stop. It was such a big deal. And so, yeah, you gotta, yeah. So, yep. So anyhow, yeah, tell them how much you love them and they trust you. But yep, zero sugar. Yeah, see, I know zero sugar is true. There's no sugar, but the aspartame is the artificial sweetener that gives it that. It's like 300 to 600 times sweeter than regular cane sugar. So but yeah, zero sugar, yes, and zero calories, and also zero benefit to your health, in fact. So in fact, it's probably negatory. I mean, there are certain things that it's kind of a wash, right? When it comes to maybe consuming, it's like, zero, no, it doesn't really benefit, doesn't really hurt, doesn't harm, blah, blah, blah. That's one that I think probably has that, not probably, that one has negative effects. They should call it negative, instead of Coke Zero, Coke negative. Yeah, but negative doesn't sell. Oh, negative does sell, so I'm surprised they don't just pump it out as that. But anyway, we're trucking. That we have to veer back on to the main drag because we've been off at this oasis and this rest stop long enough. We rated the healthy vending machines. Now it's time to get back on the highway. We do have a couple of oddball vein names. For the most part, though, they go right in line with arteries. We have the jugular veins bringing blood back from the head. So carotid up, jugular back down. And then we also have the longest vein in the body. It starts right around the inguinal region and heads all the way medially, all the way down to right around the top of the big toe or the first toe. They call it the great saphenous vein. So that's right. It's great saphenous, Saphenous, great saphenous. It's the longest vein of the body. That's the one they deal with when you're getting a bypass done. Oftentimes, people with a bypass that have had bypass surgery will say their leg is more sore than their chest. So anyway, there's another one, and we'll look at it in close up here. We're going to talk about the hepatic portal system in a couple of minutes as well, but we'll focus more on the hepatic portal. Hepa, of course, means liver, so that's coming up in a second. But before I show you that, there's this median cubital that I talked about earlier when it comes to drawing blood. So we have three major veins in the upper arm. The primary one, of course, is the brachial vein, but we also have what's called the bacillic and then the cephalic vein. And these all dump into the subclavian, which then dumps into the superior vena cava. Okay. So anyway, the bacillic is kind of like, you can see how long it is too. It starts right around the armpit area and it kind of continues down. The median cubital comes off of it, but the bacillic it continues all the way down, kind of along the ulnar area. So it's kind of like the great saphenous vein of the arm, the bacillic. Oh, and the color coding, they've got the deep veins and the more superficial veins. I don't know, you can't really tell as much on here, but you can kind of see like the median cubital is a superficial vein. Again, that's the one we go after for blood draws. Yeah. And then these are the darker ones are the deeper veins. Anyway, here we go. And then we're just about done. Lymphatics like 10 seconds. So we're halfway between third and home now. This is the hepatic portal system. Again, we're going to see this extensively next Tuesday when we do digestion, but I do want to introduce you to it because it is kind of an oddball system for bringing venous return from kind of basically the abdominal viscera. So basically the whole GI tract, the from the stomach to the colon, and then a few other spots, including the spleen. So we've got the stomach, the small intestines, large intestines, spleen, all sending their venous blood not into the inferior vena cava. They actually dump their venous blood into what they call the hepatic portal system. The hepatic portal system is three veins coming together from your abdominal viscera. We see the splenic, in the inferior and superior mesenteric veins, all dumping. We also have this little right gastric, and uh, kind of dumping in there as well. But anyway, the three big dogs, and then there's a couple other little dogs. But the idea is all of that venous blood from our abdomen is getting dumped into the hepatic portal vein. And where does it go? Well, the name tells you it goes into the liver. So the liver is going to, roughly 2/3 of blood going to the liver is venous blood from that hepatic portal. So, how does the liver get oxygen? How does it get arterial blood? Well, that comes from what we call the hepatic artery. About a third of all blood going into the liver is going to be arterial blood that's high in oxygen. What this is telling you is that a lot of blood that goes to the liver is going to have items that maybe need to be processed. So, all the stuff you consumed, all those vitamins and minerals, and maybe some of the not so desirables, aspartame, for instance, it's all going to go to the liver. If it goes in your mouth and you swallow it, it's very likely, unless it doesn't get absorbed, celery doesn't get absorbed. Celery just kind of like a bristle. It's fibrous. It's a fiber. It's a bristle brush. It does have water, so you absorb some of that. But there's very little nutritional value as far as absorbing things into the bloodstream from celery. But you need fiber, so celery is extremely healthy for you in that respect. But yeah, if you pop it in your mouth and swallow it, whatever that chemistry is on that micro level is going to get absorbed right into the bloodstream. Some of it gets absorbed into the stomach, goes right in through that right gastric, into the hepatic portal. A lot of it's going to get absorbed in the small intestine and delivered over to the liver. So that's why they tell us that, certain medications, certainly alcohol, do a number on the liver, because the liver receives anything that is going into the mouth. Anything that is going into the GI tract is likely going to pass through the liver, and it may stay there. And it's likely going to get converted into something else and then stored, or we're going to use whatever it is right away. Or if it's something less desirable, then we're going to try and figure out a way to get rid of it or to break it down. And that's the problem with a lot of foods and beverages that we consume, is these ingredients that are in them are not something that the body's used. They're synthetics. And so our body chemistry has a tougher time handling certain synthetics. And so yeah, you end up with plastics and who knows what else in your guts. All right. So anyway, last thing, couple of items with chapter 21. Again, you're just really going to look at 21.1, and you're really just going to look at a couple of different things, because again, we spend a lot of time in this chapter next semester. The lymphatic system is intrinsically linked and connected with the cardiovascular system. So basically, when we look at fluids in the body, we've already seen plasma, which is the fluid of the blood. And then when we get to a capillary network, we can pull some of that plasma can come out and get filtered, and some of the plasma's carrying nutrients. So the nutrients and the plasma kind of follows the nutrients out of the capillaries, and then the lymphatic system may pick up some of that plasma. And at that point, when plasma enters into the lymphatic system, it's now called lymph, Lymph. So the lymphatic system is kind of like a side helper filtration system for plasma. Okay, so lymphatic helps kind of cleanse or clean plasma. It also helps to regulate fluid balance. Okay, the kidneys are the primary regulator of fluid maintenance and fluid balance, but the lymph nodes are also going to play a major role in that. So then the kidneys don't have to work so hard. They've got a lot of stuff going on too. So lymph nodes in the lymphatic system really exist again as a supplement to the cardiovascular and the urinary systems to again enable our plasma to be a little bit cleaner. Now, so it has, so that would have to do then with immune system, right? Because if we have clean plasma, we have clean blood, we have clean interstitial fluid, kidneys aren't having to work super hard, liver's not having to work super hard. So what that means is, you know, homeostasis is maintained when we have a lymphatic system that's functional. So, how do we, oh, so that's the one thing, keeping things clean, right? The other thing is lymphatic system will play a role in keeping things clean by going after pathogens. So pathogens are foreign invaders like bacteria, virus, protozoans. Those are your primary pathogens. Fungus, like certain fungi are pathogenic. So if it's a pathogen and it's in the body, the lymphatic system is going to be activated. All right, so we have to clean up our normal messes, and we have to clean up messes that are made by squatters. So like viruses and bacteria, because they're only temporary, right? They call them transient. Honestly, they call them opportunistic transient pathogens. I've known a few of those, I think. Well, yeah, gotta get rid of them, right? You gotta clean them out. So that's what the lymphatic system does. Now, there are only a couple of major organs of the lymphatic system. I already mentioned one, and that's a lymph node. Okay. And then we have lymph vessels, and then we have lymph. So the three main structures or features of the lymphatic system are lymph nodes, and lymph vessels. All right. And again, lymph is just plasma that's been pulled out of the bloodstream. So we have couple other organs of the lymphatic. So we'll look at those in a little more detail in a second. We have what's called the thymus gland. We've looked at the thymus in a little bit of detail back when we were doing endocrine system. We talked a little bit about thymosin. And thymus plays a role in boosting immunity. So this is where T cells go to mature. So, or where lymphocytes go to mature. We're going to see next semester different types of lymphocytes in the thymus gland. We'll see what are called natural killer cells, helper T cells, cytotoxic T cells. So we'll see a variety of action in the thymus next semester, but just know it does help with the immune system. The other thing you want to know about the thymus is that it kind of peaks out from birth until late adolescence, maybe early 20s, late teens, early 20s. The thymus starts to shrink a little bit and deteriorate a little bit, even in our 20s, starting in our 20s, 30s, 40s, and so on. By the time we're elderly, then you can imagine the thymus is pretty well gone. It's pretty well shriveled up. So elderly folks, among other reasons, are immunocompromised oftentimes, right? They just can't seem to kick colds quite like they once did, or well, we're seeing it with COVID, right? Elderly folks more susceptible, and although COVID seems to be across the boards, right? Although kids, they're saying kids seem to be least affected, but kids are resilient, right? They're not sucked into aspartame and sucralose. They're not hooked on that stuff yet, right? They're not hooked on other things. They're hooked on phonics, so they don't need to worry about COVID catching them. All right. So anyway, thymus gland right around kind of sits on top of the heart. And then let's see, we've got a couple other items of interest. We've got the adenoids and the tonsils. So we'll look at those coming up. We've got the spleen, kind of like a blood reservoir. So we'll also look at that. Hold on. There's a couple things over here in the chat. Let me make sure I got my ducks in a row. Jeopardy question, right? Opportunistic transient. Who is my brother? Yeah, that's classic. Yes. Hey, Lori, we need a new Alex Trebek. So there you go. Yeah. You've got the right name. Tweenstra? Is that how you pronounce it? Toonstra. Okay. Lori Toonstra. At least a contestant, right? Maybe Price is Right. Come on down, right? Roddy. Yeah. The Reading Rainbow guy, huh? That's going to be the new Jeopardy dude. Levar Burton. Yeah, I heard he was in Levar Burton. Yeah, is that factual? I heard he was in the running. He was in the list. They had a short list of about 5 people, and Levar Burton was one of them. He's great. Ken Jennings, of course, they threw his name out there too. But anyway. All right. At least the name of a punk band, Opportunistic Transients. You have to add an S though on the end. Punk bands, they're very transient, right? Betty White should be it. Yeah, I'm with you, Craig. That would be awesome. Betty White would be fantastic. Yeah. Uh-huh. Betty White. Yeah. Spent many hours watching well, I know, right? That's the problem with Betty White is she's 90s. She's into her 90s, I'm pretty sure. Mid 90s, possibly. But yeah, I know she just is, well, maybe being a Jeopardy host would add years to her life. She'd get to that centenarian mark. Yeah, I spent many a Saturday evening in the mid 80s on my grandma's shag carpet watching that console TV and Golden Girls and Empty Nest and yeah. Oh yeah, Fantasy Island and Love Boat. Oh yeah, those were the days, man. Saturday nights at grandma's. All right, so let's see. Yeah, right. Hervé Villechaize, the Deplane, and Ricardo Montalban. Their real names were more interesting than their show names, I thought. But anyway, man, that was a great show. Fantasy Island. If you guys haven't seen that, binge watch that. Some pretty crazy stuff happens on there. Let's see. We're gonna make it, you guys. I promise. We're almost there. Damn, we are old. Yes, I know. We're showing our age. Oh, sweet. Hey, all right. That's awesome. Yeah, those are the soundtracks of our lives, right? Man, mixtapes with Thompson Twins and Depeche Mode and The Cure and all that stuff, right? New Order. Yeah. Yeah, Breakfast Club's awesome. All those, I think it's John Hughes or one of those, the Pretty in Pink and 16 Candles. Yeah, right. That's the good stuff right there. I'd like to do a course just on oh man, Uncle Buck. Yeah. Yeah. John Candy and Dan Aykroyd I mean, you could put and throw in Chevy Chase. You could put those three, they could just be standing around doing nothing and it would sell like hotcakes. Yeah. I love Uncle Buck. It was great. Yeah. Oh, and I was saying Great Outdoors. I said Dan Aykroyd, but yeah, Great Outdoors, Dan Aykroyd and John Candy. Oh, geez, man, yeah, they don't. And yeah, RV. You guys, you remember, yeah, I don't know. We're sounding like our parents when we say stuff like, "Oh man, movies used to be so much better," right? Man, and music too it was so much better. I don't know what happened. Movies are just I don't know if any of that's true, but I know that's a sign that you're old when you start saying stuff like that. So, yeah, I'm not hiding from it. Those were the best years for oh man, the 80s and early 90s. Great comedy. All right. Or the Naked Gun franchise, those were great too. Leslie Nielsen. So, but anyhow, oh, you guys watching Cobra Kai? Yeah, I hope so. You got to get your Karate Kid on, right? Johnny. Yeah. So I think season 3 or 4 or whatever is that's coming quick. I want to maybe January. I'm not sure. Yeah. So yeah, Cobra Kai, bring it on. Let's see. Man, I'm done, right? You guys know that. All right, so I said done, D-O-N-E, not dumb. Well, I am that too sometimes, but anyway, yeah. I gotta get going here, but we don't have time for that stuff. I know too much reading and home. I know. I should start giving you guys movie assignments. Maybe I will for advanced. There's some medical stuff, right? What's that one? John Q, I think it is. It's got is that not Wesley Snipes, the other John Q. You guys know that movie? You guys seen that? Denzel Washington. Yeah, Wesley. That's an insult to Denzel, right? Oh, Wesley Snipes. Geez, what he was passenger 57 or something? I don't know. But yeah, Denzel Washington. Denzel for president, right? He's awesome. He's a good dude. So yeah. So anyway, yep. Yep. About insurance, right? Oh man. That gives me chills right now just sitting here. I'm serious. I'm getting them right up here. They trickle right all across my front of my skull and into my back and down my spine. Man, yeah, flatliners. That's a good one. Yeah, yeah. But oh yeah, you get me going on that racket. We'll never leave. You guys will be. I'll be talking to the screen. It'll be 3 a.m. and I'll still be babbling about the insurance. So many movies Denzel did. Someone asked what he did. That's my favorite. Yeah, yeah, yeah. Nice. Um, yeah. Maybe I'll have that as a movie for next semester. No. There's some really good documentaries on what we're talking about too. In on Netflix have got some good ones. Forks Over Knives and Fast Food Nation. That was there's a Food Inc. That's really good. There's another one called Corn King with a C, corn with a C, King. Yeah, careful. All right, Corn King. That one's awesome. There's another one called The Business of Extra Credit. There you go. Okay, Lori. All right. Um, maybe. Well, for advanced, yeah, we're a little late now for general, but yeah, maybe for advanced. So, all right. Well, anyway, you can see lymph vessels connected, intertwined with these capillary beds. Again, how are we going to get plasma into the lymphatic system? Well, at a capillary bed. It's the only place we get anything out of the blood or back into it. So lymph vessels have these little flaps on them that allow for the plasma or the lymph, the plasma to enter in and be ultimately become lymph. Now, I wanted to mention too that in between like all this negative space, so it's not like the fluid doesn't necessarily go directly from the capillary into the lymph vessel. It goes into what we call the extracellular space or the interstitial space. So this is also called interstitial fluid. So this says tissue fluid, but here you see, you have it right here, interstitial fluid. So we basically have 3 major kind of compartments of fluid in the body. inside of the cell. We call it intracellular, and then extracellular, outside of the cell. So those are the two main spots where fluid is. Fluid's either inside of a cell or outside of a cell, all right? And if it's outside of a cell, we call it either interstitial fluid or plasma or lymph. So those are your three extracellular fluids. All right. So intracellular fluid would be like cytosol, right? Cytosol, cytoplasm. Okay. And I want to say, I think about 2/3 of water. It might even be a little higher, but I'm pretty sure right around 2/3 to roughly 70% of water is intracellular or fluid. Okay, so the fluid in our bodies, 2/3 to 3/4 of it is intracellulars, inside of our cells. The rest of it is in our blood as plasma, in our lymph vessels as lymph, or in between called interstitial fluid. So that balance has to be maintained by the kidneys, by lymph nodes, by other lymph organs. By the way, too, all of this lymph is going to dump into, some of it gets picked right back up into the bloodstream, but a lot of it, lymph vessels have valves. So there's kind of a one-way flow for lymph. Okay. So once plasma gets into the lymph vessels, for the most part, it's going to stay in there and it's going to get kind of squeezed in the same way venous blood does. So we see lymph vessels around muscles. We see lymph vessels really all over the place, but we see them concentrated, especially around joints. We see lymph nodes concentrated around major joints. So we're going to see lymph nodes concentrated around the breast and axillary region, as well as in the inguinal or kind of the groin area. And then we also see a lot of lymph nodes in the throat area, the neck area. So anyway, movement, again, more reason that sedentary lifestyle is bad. We need to get that fluid, moving back to ultimately to the heart. But if it's lymph, we also need it going back towards the heart into one of two ducts, D-U-C-T, duct. We have what's called the right lymphatic duct. So basically all the lymph that's in your right arm, on the right side of your head and on the right side of your upper body, all of that fluid on the right side is going to dump right up here into what we call the right lymphatic duct. And then that's going to dump so that lymph fluid is actually going to be reintroduced to the bloodstream at the subclavian or the right subclavian vein. So the right subclavian vein dumps into the superior vena cava, and all of that lymph fluid is dumping into that spot. Okay, just from the right arm and the kind of the right side of the upper body. Everywhere else, the left side of the head, left side, left arm, left side, and then everything below the diaphragm pretty much is going to drain into what they call the thoracic duct. Why isn't it called the left lymphatic duct? I really don't know. This is one of those situations that just doesn't make sense. There's probably a lot of them that arguably, right, in anatomy that don't make sense. But this one really is a stumper to me. Right lymphatic duct is where all the lymph drains from the right side of the head and then basically the right appendage and right side of the chest. So everything else, left side, shouldn't it dump into the left lymphatic duct? No, it should, but it doesn't. It dumps into what they call the thoracic duct. So anyway, whatever. All right. Either way, you do need to know that. And then there's something else too I wanted to mention. There's a cistern. A cistern is kind of like a collecting container. I think a lot of farmers and a lot of folks will have a cistern on their property to collect water, like rainwater. So we've got a cistern just below the diaphragm, a little bit kind of, I don't know, kind of around where the stomach and the pancreas and small intestines is kind of in that area. You can see a little bit where they're trying to show where it's located, but it's called the cisterna chyli. Um, and again, uh, we'll see chyme, chyme, and chyle or chyli. These relate to digestive juices. So if you do see chyme or chyle, it's going to have something to do with digestion, digestive juices. So keep that in mind. But anyway, the cisterna chyli, uh, we have a lot of need for lymph nodes and lymph vessels and lymph fluid down in the intestinal area. This is near that hepatic portal I mentioned earlier. Again, everything you consume, good, bad, and ugly, is going to end up in the plasma, right? It's going to end up in your bloodstream. So just we have what we'll see next week in digestion. We have what are called lacteals. They're kind of like specialized lymph nodes or vessels that deal with fats in the small intestines. But anyway, there's a lot of need to keep things clean, right? And there's also a lot of need to keep pathogens away, because generally the main route of pathogenic entry into the body is through the nose, nasal cavity, and respiratory, but also through the mouth and into the GI tract. But the acidity of the stomach oftentimes eliminates and kills a lot of pathogens. And then certainly we do have a pretty vast network of lymphatic nodes and other specialized lymph tissue in the intestines, just because a lot of stuff's getting in there that maybe shouldn't. And so humans have, all animals have these. I mean, animals eat stuff they shouldn't too. I mean, we're not and it's probably because of us, right? Some of the junk food that animals eat is probably humans junk that they've left sitting around. There's a guy on YouTube. I think he's called the Raccoon Whisperer, and yeah, you should check that dude out. He lives, I think, up in Canada, like New Brunswick or somewhere in Halifax. That's Nova Scotia. He's from Nova Scotia, but yeah, this guy, real old guy, big bruiser, and yeah, the Raccoon Whisperer. Yeah, YouTube that cat. He goes out on his back deck almost every night with 5-10 pounds of hot dogs and Oreo cookies and um I've seen, well, I don't know what the hell else I've seen him throw out there, but um oh yeah, well, dog food. But anyway, he goes out, he sits on his bench, and he'll get 15 to 20, 25 raccoons. They've got names. He has baby. It's bizarre. So but anyway, yeah. So raccoons, right? They're gonna have a cisterna chyli too. I see, yeah, oh crap, right, 40 raccoons. I know, right? Uh, Lori? Yes, they can. Do water pills affect the lymph system, or just do they draw from main arteries and veins, causing lymph to drain? They're actually probably going after the kidneys first and foremost, and then that's going to create kind of a trickle effect um, with the lymphatic system. So um, kind of an all kind of an all or nothing deal. Yeah, if when we're dealing with trying to draw water away from the lymphatic system or from the interstitial spaces or from the bloodstream, um, in essence, yeah, getting lymph to drain. Um, if we have problems with that, then we definitely are going to have problems with the kidneys. So we oftentimes they're kind of part and parcel, typically. Now, there are traumas too that can happen to the lymphatic system, just to them, even to joints or the musculoskeletal system, that can lead to something called lymphedema, where where fluid builds up. The lymphatic system is unable to; it's not pumping the lymph back into the right lymphatic duct, and the thoracic duct are both malfunctioning or dysfunctional. So it can lead certainly to a real problem. Oftentimes, unfortunately, the lymphedema leads to amputations. It's a horrible way of living. Unfortunately, and again, I don't like to be gloom and doom, but I do like to be realistic. We had a patient; she was totally normal person. She was broadsided, I think T-boned. She was driving and she got T-boned by somebody blew through a red light. So she was somewhat injured. I mean, she had a seat belt. She's driver's side seat belt, broken collarbone. It like basically smashed in, this side of her collarbone. And so anyway, she had a broken collarbone and maybe a broken leg, but after normally something like that, after 6 to 8 weeks, patients should be on the road to recovery. Yeah. But this particular lady, because of just, I mean, it's split like a game of inches, right? They call life, they call baseball, they call everything. It's a game of millimeters sometimes. But the direction of the break of the collarbone nailed her thoracic duct, which then subsequently caused clogging in the back, preceding it, which thoracic duct drains everything below the diaphragm pretty much, and then the left. So then the right side had to take up some of the slack, and it couldn't. So it autoimmuned itself to going on strike. And so then she had a complete shutdown of both lymphatic ducts, all because of a T-bone shot. And she could never get it healed. It never repaired. And by the time she got to us, she was amputee, both legs above the knee, both arms above the elbow. So, and it happened 2 years before that. So that's how fast things can snowball. You get up in the morning, you appreciate every day you have, the simple things, right? Tying your shoes, wiping your butt, brushing your teeth, opening a can of Coke Zero. Don't do it. Anyway. Yeah. So yeah, that poor woman's life changed. Had nothing to do with her. So yeah, lymphedema is a bugger. Water pills are a variety of different types. Usually what they're doing is trying to affect fluid and electrolyte balance. So they're going to oftentimes go after diuretic principles of the kidneys, which subsequently leads to then less stress on the lymphatic system. Oh, bone marrow, of course, is where all this action's going, and where we see a lot of your lymphocytes, right? Your white blood cells are produced in bone marrow. Let's see. I'm going to zoom through. We've already seen. I don't need you to know specifics right now about the thymus. Next semester, we'll go through some of the specific thymocytes or T cell lymphocytes. We do see this cortex or outer kind of shell, and then the medulla on the inside or deep to the cortex. We saw the same setup with adrenal glands. So keep that in mind as well. Again, not a big deal. Just know the thymus is in the chest. It deals with the lymphatic system. We see T cells maturing there, and with age, the thymus gland tends to deplete, diminish in size. We see the same thing. Kind of a lymph node is kind of like a glorified mini kidney. It's got an outer cortex. It's got this inner kind of medulla area. It's got these what are called trabeculae. That like we saw with spongy bones. So the lymph nodes are going to have a little bit, they're kind of like a jelly bean. They're kind of hard, but if you squeeze them, you can get, it's not like squeezing a pebble where you're not going to get any, it's rigid. But lymph nodes range in size from the size of a pinhead all the way up to, I mean, in essence, like your tonsils are large lymph nodes, so it's the size of a gumball. You have about 600 lymph nodes scattered throughout the body, roughly 600. And again, we see them concentrated in the armpits and groin and breast area. We also find them in the throat and in the abdomen. We have afferent lymphatic vessels and efferent lymphatic vessels. Okay, so afferent and efferent, right? So afferent goes in, efferent goes out, right? Like the sensory goes in, motor goes out. So we've seen these terms afferent and efferent before. So we'll definitely see these again coming up when we do the kidneys. We'll see afferent arterioles and efferent arterioles. Okay, so there's more than so. In other words, lymph can go into a lymph node, kind of gets filtered a little bit, and then it leaves the lymph node while still in the lymphatic system. So we have usually more pathways going in than coming out. Anyway, we'll look at afferent and efferent again. Spleen, again, generally for the spleen, you want to remember that it's in the left upper quadrant. The spleen is a blood reservoir, so it kind of is like a sponge or a storage unit for blood. We see red pulp and white pulp associated with the spleen, and we'd oftentimes may find what are called monocytes, which are one of our leukocytes or white blood cells. If you get mononucleosis, they can cause spleen enlargement due to some of the production of excess monocytes. So even after a bout of mononucleosis, we usually want to make sure that the patient is avoiding a lot of physical activity, even for a few months after they've kind of overcome or been healed from it. So I'm losing it. So that's good because we're just about done. Oh yeah, I know. Mono's brutal. Yeah, I'm knock on particle board, but yeah, that's my wife had it. Before, I knew what you meant. Wouldn't. That's Southern for wouldn't, y'all. So yeah, she was laid up for quite a while with mono. Oh, tonsils. Pharyngeal tonsils are going to be up kind of in the nasal pharynx. So past that little uvula, that dangler in the back of your throat, you kind of go up past the soft palate. There's what are called adenoids up there, pharyngeal tonsils. And then we have what are called palatine tonsils. Those are the two big ones that you can actually see, the palatine tonsils. Oh, here we go. You can see this is the uvula. So we're looking into the mouth here. So this person's got their mouth open. We got the hard palate out front, soft palate kind of terminates at the uvula, that little dangly jobber. And then we can see the palatine tonsils. And yeah, these says swollen due to infection. Yeah, they look a little rough. Sometimes they'll get white patches on them. They'll remove them. Sometimes tonsils will get, right? If you get too many tonsillitis bouts showing up to the doctor too often, they'll just take them out. And if we go up, so if we go past the palatine tonsils and kind of up in this area here above that soft palate, that's where you find the pharyngeal tonsils, or adenoids, they call them too. Oh, yeah. Good, Lori. Yes, absolutely. Tonsil stones. Yep. Yuck. They make your breath stink, and they can kind of hurt. Yeah. I feel it's like a collection of it's lymph, right? It's kind of like infection that's been, pushed out of the tonsils. Yeah. Katie, my wife's Katie, she would get, you know, she had mono, say, I want to say 2000, 2001. And even up until probably, oh, I'd say 5, 6 years ago. So probably like 12 to 15 years after she had mono, she would still get the occasional tonsil stone. She hasn't had one for years, but she was almost sure that it was still her body just working on getting whatever out of her. So yeah, mono is a bad deal. It can affect your immunity for a long time. Yeah, there you go. Nice. Yeah. So, um, make sure you do like uh boost your magnesium levels, probably zinc, like just daily. Like I don't generally suggest or recommend. I mean, if you're eating the right stuff, but I would say calcium, magnesium, zinc supplements a good one that'll help boost immunity, help with those. Make sure you gargle with like Listerine, something heavy duty too, to that can and really work on the gargling aspect. Maybe breathing exercises. Some folks get into doing like yoga and certain like movements to open up those areas. And again, just getting the breathing but it could take years. It took Katie, like I say, probably 12 plus years before I mean, I don't even know she hasn't had one for quite a while, but it's been several, probably 5 years, but yeah, she's sure it was because she never had them before, before mono. But she was running herself rag. She was in college at the time, and she had 2 or 3 jobs and, living that college life on top of it and a bunch of classes and, you just burning the candle at both ends, and eventually your body just crashes. It can't take it. And sometimes it's mono. Yeah, that does it. So, again, these are opportunistic transients. So, if you give them an opportunity, they'll set up shop, man. They'll raid your fridge, and they'll, you know, steal your remote, leave messes everywhere. And what do you do, right? Got to give them the boot. So anyway, that's it. I'm done. You guys have fun. It's I don't know what time it is. Time's flown by. Oh yeah, we're done. Crime in Italy. It's almost 9 o'clock. Well, that's normally when we would go to anyway. But you guys have fun tonight. So Thursday, we're gonna jump right into Unit 9. Well, we won't jump right in. At the beginning, I do want to pull up a couple things with the Unit 8 portfolio. Maybe discuss a few other things, show you a few things on Blackboard, and then we'll jump in Unit 9. Respiratory should only take us maybe an hour and a half to get through. I don't think we just have to, you already know a lot of it. We've already talked about the nasal cavity, the sinuses, the pharynx, the larynx, trachea, bronchus, right, or the bronchi is the plural. And then we have bronchioles and then alveoli. That's it. See, that took about 30 seconds. We're already done with respiratory. So I'll at least show you a couple of nice, pretty illustrations or images. But that's it. It won't take us that terribly long. And then that'll be that. And then it'll be the weekend again already. So, well, you guys have fun tonight and stay warm. It's chilly out. But I think Thursday might be back up into the low 60s. So that's a plus. We like those temps. So, yeah. And hopefully guys aren't doing anything too wild and crazy for Thanksgiving. Because, well, they're telling us, avoid our families. Well, sometimes you don't have to tell me that, COVID or not, right? So, what a convenient excuse this COVID's been for a lot of things, right? Social stuff, darn. So, but anyway, standing in line for a PS5. There you go, Carolina. Nice. All right. My kids are badgering me about a Nintendo Switch. That's the route they want to go. They've got a, we have a, we've been Wii, we have had a Wii and then the Wii U. And so they're getting kind of burned out from the Wii U. So yeah, it's probably going to be Switch time. They love anything Mario or any of that other stuff. So, and I do too. I grew up on Atari 2600 and Nintendo.